All right, quick sound check, sound check. Okay, I can hear myself. Welcome to our TEAS 7 review. Welcome, welcome, welcome. My name is Brandon Piasecki, and I'm excited to be here with you today. So exciting. Today we're going to talk about valence electrons and do a little ionic bonding review, talk about that a bit, and then talk about covalent bonding. It's going to be awesome. Talk about chemical bonds, building off of previous topics that we've talked about. Welcome, everybody. Welcome, welcome. All right. We'll give folks like one more minute to join, and then we'll get into it. And thanks for being here, y'all. If it's your first time here, welcome. My name is Brandon Piasecki. I am a science educator. It's my only job I ever had because I love it so much. I'm in my 15th year of teaching science. I taught chemistry for over a decade and in the classroom, and now I've been teaching chemistry live on TikTok with NurseHub. And I'm currently in middle school science, teaching middle school science now in the classroom. Love my job, and I really love this chance I get every week just to scratch my itch for still teaching just the concepts of chemistry that I got to teach in the high school level and also the college prep level. So yeah, it's really, really exciting to be here, and I really value this time. It's fun to be a part of your journey to become nurses. I feel like really honored to be a small role in that journey for you. All right, so if you're just hopping in, we're talking about valence electrons, which we did briefly get into similar topics last week. If you're returning, I like to kind of build on the previous weeks as we cycle through these topics. So let's get into it, y'all. Valence electrons, ionic bonding, covalent bonding. We talked about ions last week and isotopes. So today we're going to see, like, okay, well, what do we do with those things? Okay, more so ions. But let's talk about this big idea of valence electrons. I like to structure my lessons with some notes. Okay, notes first, and then some quick questions to check understanding, and then the questions I need that engagement answering in the chat because it helps me know if we're getting it or not. Okay, and I'm glancing at comments as we're going. If you have questions that come up, please ask. All right. So let's start with this definition, y'all, and I'll go to the simulation below in just a minute. But valence electrons, this word valence, I help students remember what this means by using the phrase like or thinking of the word veil. Like if you veil something, you're covering it, right? So think of these electrons are kind of covering the outermost part of the atom, and that's what they are. They're electrons in the outermost orbital. There's a new word, orbital. We'll talk about that in a second, okay? But that's just a word to describe like where the electrons orbit around the nucleus, okay? They are important because they allow atoms to make bonds with other atoms. Like this is the name of the game for how atoms connect. If we didn't have valence electrons, atoms could not connect together. So they're very important, all right? The big idea that I want to get across today is that atoms connect with other atoms using valence electrons. And there's like two major types of bond that we're going to talk about, and that is going to be covalent and ionic bonds. Okay, so let's first visualize. I love to, when I can, provide some kind of visual for students to see, because chemistry is really hard. Like, we can't see a lot of what we're talking about. You can't see atoms, right? We only can sort of imagine what they might look like based on experiments. Now, as I'm doing this, I'm going to throw some quick review at you. Over the last few weeks, I've been covering parts of the atom. Okay, Mitch, what's going on? Great to see you. And one of those parts is the nucleus. Okay, the nucleus is the center of the atom. Okay, and then these dashed lines, these circular lines, represent what are called orbitals. Okay, see this word, orbits, same idea. And we can see basically, like, as electrons are added, okay, well, one, you know, they're going to take up space, right? Electrons are negatively charged. If you pack too much negative charge in one space, think of two magnets that you take off the fridge and then put end to end. They're going to repel each other. So you'll notice these electrons are going to want to spread out. They're not going to want to be in the same area, even in the same orbit. So they're not going to want to, you know, there's going to be a limit to how much we can put. And so when we find that limit, like, there's going to eventually be this outermost orbital, and that's a valence electron. So right here in lithium, a neutral lithium atom is going to have one valence electron. That's a valence electron right there. Okay? So there's one valence electron in lithium. Okay? I'll show you another one. If I add more, okay. Also, reminders, quick review, nuclear stability. The neutrons are the thing that are going to keep the nucleus stable. So you notice it's unstable now. Let's add some neutrons to it, and now it's stable. We're happy, okay? Nitrogen, a nice stable isotope, review there, of nitrogen is going to have 7 neutrons, 7 protons, okay? So how can we make this charge neutral? We're going to add electrons until the amount of electrons, these negatives, is equal to the positives, the positive protons. And you'll notice now, as I add electrons, they're not going to be able to go here. They're going to go to the outer one. They can't fit on this inner orbital now. It's full, but they'll fall to the, or, you know, naturally to kind of spread out here in the outermost. And still we have a nice valence electron here. But in the chat, can you tell me now, how many valence electrons do you see in nitrogen? In the chat, can you count those up? A lot of folks just joining in. I looked up, it's like 38 people in here as opposed to, I think, 18 the last time I looked at the count. So thank you for joining. Thanks for being here. Today we're talking about valence electrons and chemical bonds. Awesome. And someone said, like, yeah, it is kind of like that. It's a similar model. And honestly, this model of the atom, it's one of those models where there are some inaccuracies to it that I'm not going to get into, but it gives you the basic idea, and it's known as one name for it is the planetary model for that reason. Yeah, in the chat, you said 5. Yes, nitrogen has 5 valence electrons, okay, because it has 5 electrons on the outermost orbital. Nitrogen has 5 valence electrons. Okay, and this is important because the number of valence electrons and an atom's position in the periodic table is going to help. Oh, no problem, Zach, I got you. I love this, yeah. The number of valence electrons is going to help us understand how it bonds. I'm going to say that again. The number of valence electrons and the position on the periodic table will help us understand how an atom bonds. Pause for any quick questions. What questions are coming up for folks from this first slide, this first section? Okay. So now let's do a quick check for understanding. One more in the chat. How many valence electrons are in the following atom? It's an atom of carbon. Take a look. Is it 2, 4, 6, or 12? In the chat, give your best answer. Go, 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 go. Thank you, Kayla. Thank you, Nikki. Thank you, Evelyn. Good, good, good. Thank you, Neek. Great to have y'all here. I recognize a few from the previous sessions. So good to see you again. Yes, if you said 4, you are correct, because the valence electrons are the outermost electrons that we see. All right? There are a total of 6 electrons in carbon, but 2 are low, we say lower energy. Okay? These are lower energy, okay? And the outermost electrons are going to be higher energy. So, that was great. Let's keep going. What about this one? This one's got some more electrons. Take your time, look at the picture. How many valence electrons are in the following atom? Awesome, got several responses coming in. Yep, put the number if you want, that's fine too. Well done, well done. So now, if you said 7, that's correct. Yes, let's count them up. We're not counting these, we're not counting these, we're counting just the outermost. 1, 2, 3, 4, 5, 6, 7. All right. I want to show a quick visual of ionic bonds today. So, ionic bonds are when an atom gives an electron to another. Yes, to stamp it. Yes, in the chat. Valence electrons are outermost electrons. Yes, and so when we see an atom just giving an electron or transferring an electron to another atom, that's called an ionic bond. And I'm gonna talk about why this happens in a minute, but I want to give a visual. Just watch this for another like 10 seconds and see like, all right, like this is an ionic bond. A couple things are happening. One, the sodium's giving an electron away, but then notice how there's a negative ion that forms, okay? And a positive ion that forms, okay? And this is all made possible by valence electrons, okay? Now, there's another way that we can interact as well. There's a covalent bond, and that's when these electrons are shared in an orbital. Okay, we're going to talk more about it and define it, okay? But I like visuals. So you see there's a difference here. This is where the electrons are shared between the atoms. Okay, and we'll come back to these visuals as we continue to define them. Now, both ionic and covalent bonds happen because of this, the octet rule. So atoms tend to be stable when they have 8 electrons in their outermost, their valence orbital. This is called the octet rule. Okay? Sorry, little man, we ain't got no more space. We're a full octet. Like this silly little cartoon to show there's 8 electrons, they're full, they can't fit anymore. And that's kind of what I was talking about. Like when I was showing you the simulation, we weren't able to fit even the lowest energy level can only hold 2. And this is like, again, the trend. 8 is most common. A few exceptions like hydrogen, helium, those are tiny atoms. 2 is the most they can hold. But most atoms can hold more. and most are going to follow this rule, the octet rule. Okay? So let's zoom in here for a minute. Okay? And define ionic bonds and then connect our concept of the valence electrons with this. All right? So ionic bonds to form when a metal transfers its valence electrons to a nonmetal. Okay? Ionic bonds are when there's a metal and a nonmetal. Okay? That's key. If you're able to recognize that there is a metal in a compound, then you can bet that it is going to be an ionic bond. So, some tips. Metals end with M. Okay? You'll notice on the periodic table that metals end with M. There's some exceptions, like iron is a metal. Okay? But for the most, and there's other ones as well. But the ones that we're going to need to be worrying about, like nickel, like I get there's some exceptions, but all these EMs, those are metals. Over here, you'll notice there's not any EMs. Oxygen, fluorine, chlorine, sulfur, those are nonmetals. So I like this periodic table. If you go to the website, I'm going to plug it. It's just a nice free website, ptable.com. Okay. It's great because it categorizes by color. And you can see, okay, this is all the nonmetals here. So typically when you have something from this group over here bonding with a metal or some one of these, it's going to be ionic, okay? And what that looks like is, let's try like this. What that looks like is here. Sorry for the all the moving around. It looks like this. All right? Like we just saw in the animation. Now, when this transfer happens, let me show you kind of why it happens. We talked about the octet rule, right? Just trying to move this away a little more. Can I? Okay. Let's focus here. Sodium, Na, on the periodic table, it's got 11 electrons. Okay? It's got 2, then it has 8, and there's one more 11th electron that it has, so it's got this 1 valence electron. Okay? 1. Valence electron. And on that 1 valence electron, with that 1 valence electron, it's trying to fulfill its octet. Okay? It's trying to fulfill its octet, like we talked about the octet rule. 8 is great. Chlorine's got 7 valence. So guess what, y'all? Look, 1, 7, add them together, you get 8. And so what we see happen is the sodium transfers its 1 electron over to chlorine. And that's what animation is showing. Okay? Firmly stamping it, ionic bonds form in metal when a metal transfers its valence electrons to a nonmetal. Exactly, and this is your typical table salt right here. This is how table salt forms, okay? Pausing real quick for any questions about ionic bonds. Yep. Yep, metals ending in em. Like, that's going to be a really helpful clue, y'all. Now let's talk about covalent bonds. Okay? With covalent bonds, there's not very many nonmetals that exist compared to metals. There just isn't as many that exist. But there's a lot of different combinations that you can get. And the difference between, you're not as limited, I guess, is a way to think about it with covalent bonds. As long as you can have a number of shared electrons that equal 8, these atoms are going to be happy. All right? Oh, thank you so much. I really appreciate that. Thanks for being here. So covalent bonds, they form, let's define it, when the key here is two nonmetals. Okay? Two nonmetals. I'm going to show you real quick on the periodic table what that looks like. Okay, again, love this website. It's really great for reviewing. I'm going to address a quick question I often get, and that is like, do I need to memorize the periodic table? The answer is no. No, you do not. But I will say there are some parts of it that I would memorize and that you will honestly, naturally become pretty proficient at the more you study and come to these lives and do practice questions with Nurse Hub and all that fun stuff. So I would memorize like this part right here. Okay, these are going to come up a lot. More so like from around like the 4th row up. Okay. But still, I would say that. And then this right here, like this section right, let me make the color a little easier to see. This right here. And right here, these are oh, come on now. These are nonmetals. Okay? Oxygen, fluorine, nitrogen, carbon, phosphorus, sulfur. And like where's my other slide at? There we go. And I want to real quick remind us, like we're looking for 8. 8 is great. Okay? So an example where 8 is great and works in covalent bonds where we're sharing electrons. It's kind of like a potluck, y'all. It's like let's all bring enough electrons so we can all share. You share with me, I share with you. We end up with 8, and we're happy. One nitrogen has 5 valence electrons, and each hydrogen has 1. So guess what? Nitrogen says, well, look, I don't need this one hydrogen. Bring 2 more friends, hydrogens, and we can all have a party. Okay, there's 8 valence electrons here. Same with water. Water is a covalent compound because when you have 1 oxygen, there's 6 valence electrons in oxygen, 1 from each hydrogen. Okay, oxygen says, bring another hydrogen. There's 2 hydrogens, 6 oxygen valence electrons. I got 8 total. Chlorine, remember we talked about chlorine having 7. Well, guess what? If chlorine, each one is sharing that single kind of leftover electron, well, guess what? Now they each are able to have 8 in their total valence electron. That is a great question. Let me go back to that in just a second, okay? When I say memorize, I memorize a couple things. And I think I'm going to jot down on this like a little list for you because I think it would just be really helpful. Give me just 1 second. So I'm doing a little sidebar here because I think it is important. I think for periodic table, like what to know. Here's what I would focus on here. I would memorize atomic number and mass. And I'm going to up front say it might look like a lot. However, like I said, a lot of this you just become familiar with by practicing and by exposing yourself to just using the periodic table in a question. And I'm going to give you all a tip for this next one. I memorized the group. Sorry. Trying to make my handwriting a little neater, y'all. It's one thing, like as a teacher, I've been teaching 15 years. My handwriting is still like the worst, you know? It's just not, it's not what you would expect like a typical teacher to have. I'm really trying though. I said the group number. And I would say, I'm going to add this, even though you'll learn in the next slide or two that group number and valence electrons, actually there's a pattern there. Okay? Right. I would also memorize, like, if you know that covalent bonds are with non-metals, then you're going to be set. Because metals end in M, and if it doesn't end in M, it's going to be a non-metal. Okay, and the only exceptions to metals ending in like different letters are ones that we actually talk about in everyday life, like iron or nickel. Like I think we know those are metals. So like the more obscure metals all end in M. So I would add this number of valence electrons. I'm going to pause there, screenshot it, jot it down. This is, I would say if you know these things, oh, sorry, what had happened just there? Let's do that. If you know these things, you're going to be set. Like if you know this, you're going to be so set. Okay? Let's keep this up, y'all. Keep it up. Keep it up. Love the engagement and the questions. Like I really appreciate that question because it's in the past I've kind of just vaguely said memorize this. But like, what does that mean? I appreciate that question very much. It's helping me be a more effective instructor. Okay. If you need me to come back to this, drop a comment at the end. I'll come back. Okay. This is an easy way to check if a bond is covalent or ionic. This pattern here tells you the valence electrons in each group. Don't worry about these in the middle. I'm going to straight up cross them out because you're not going to get a lot of questions on those. There's a lot of exceptions to those, but there's a very clear pattern that you're going to be, the questions we'll ask about for the groups that I asked you to remember. Obviously, you don't remember every single element in the group, but like, aluminum's right here, carbon's right here, and I told you to kind of do like this section. These are kind of the main ones you'll see a lot of. These are the main ones you'll see a lot of here. I'll outline again kind of the parts I was asking you to memorize. It's kind of like, so it's not overwhelming, right? Like we don't want to overwhelm each other. But I think if you did commit those memory with some flashcards, maybe a Quizlet, maybe, however you want to do it digitally or old school, index cards are great too. It would go a long way, just like, 5-10 minutes a day, and just really get those down. And again, like I said, using the periodic table really helps. So here's some quick ways if it's a covalent or ionic. So if it's a metal, if there's a metal, if you see literally like the name has an M in it for one of them, and then another non-metal, it's ionic. Metal plus non-metal is ionic. If it's a non-metal and another non-metal, it's going to be covalent. Now, it's important to count valence electrons, whether it's a metal, like whether it's ionic or covalent, because it's, this is more meant like also you can count valence electrons, and that's important because for either one, the 8 is great rule applies. Don't forget the octet rule. applies to both ionic and covalent. The one thing about ionic bonds is you're always going to have like two. Okay, ionic bonds are always going to just have two. I shouldn't say always. So I won't say that. Often. They often have two compounds, Na and a Cl. Okay? But no matter what, they always got to add up to 8. Like if you add an example of an ionic compound that might have 3 would be like calcium fluoride. Okay? Where calcium, it's got 2 valence electrons. I'm going to draw them with little dots. Okay? And fluorine's got 7. I'm going to draw them with some dots as well, just like this. And so just to show, you can have multiple number, but if we transfer, if calcium transfers 1 to 1 and then the 1 to the other one, now it's a nice, fluorine's got an extra electron, so it's negative. Calcium's got lost 2 electrons, so it's going to be positive. The other fluorine's going to be negative. And so it's going to end up being ionic. But yeah, so I wanted to correct myself or make sure I was clear. You can have ionic compounds with multiple of the same. But the key is the valence electron should always equal 8. This one transfers over, there's 8. This one transfers over, there's 8. Calcium's left with a full orbital that we're not going to worry about drawing, but there's 8 valence electrons in every single atom, so it's happy. Same with sodium and chlorine like we showed earlier, right? 1 plus 7 is 8. Okay? In that case. All right. I'm going to pause here. What questions are going to come up for folks here? Any questions coming up for people that I can address? All right, then let's do some practice. This is great just to see where things are landing. Okay? Gonna start with some quick review, y'all. Definitions. What kind of bond forms when 2 nonmetals share electrons? And I mean, this question could come up. Even some as seemingly simple as this could come up. And this is one of those layups that you don't want to miss. Covalent, chemical, ionic, or valence. All right, I got a lot of answers coming in the chat. Keep them coming, y'all. And quickly skimming through. Well done. Y'all crushed this one. Yes. Most of us said covalent. That is correct. Share. The key is share, right? Think of like the prefix, right? Collaborate, right? Collab, right? Cooperate, covalent. That's your key, all right? Good. Next one. What kind of bond forms when a metal transfers electrons to a nonmetal? Company, I like that as well. Yes, thanks for sharing that. Take about 10 seconds. What do we think for this one where a metal transfers electrons to a nonmetal? Got a lot of engagement, got a lot of answers coming through. Thank you so much. Take about 5 more seconds to think and respond. Is it covalent? Is it chemical? Is it ionic or valence? Same choices. All right, and if you chose ionic, yes, that is correct. Ionic bonds transfer. Ionic bonds transfer. Okay. B and D are nonsense answers. Okay. Those aren't a type of bond. I mean, technically, these are all chemical bonds. So I guess chemical bond isn't completely false, but it's just not as accurate. Covalent bond is not correct because that is sharing. Okay. Ionic, yes. Well done, y'all. Well done. Well done. Okay, now we're going to look at some elements. Okay. Try to do this from some of the patterns and tips that I've given you based on the names. Okay. Which of the following pairs of elements are most likely to form a covalent bond? Calcium and fluorine, hydrogen and nitrogen, sodium and chlorine, or potassium and iodine. What are we thinking the covalent bond choice is? Take some time with this one. Look through. If you took screenshots or notes, glance back at them. All right. Got a lot of responses coming in. Keep it up, keep it up, keep it up. We're going to go over it in 5, 4, 3, 2, and 1. Okay. So the way I think through this one is I see co. I know it's going to be a sharing of electrons, but more importantly, like that doesn't as much help me out as much as I know covalent bonds is also non-metal plus another non-metal, at least one more non-metal. I also know that metals end in M. Metals end in M. So I see calcium and fluorine. There's a metal in that one. Sodium and chlorine, a metal in that one. Potassium and chlorine. So those are all going to be ionic, leaving hydrogen and nitrogen as my covalent choice. So B is the correct one. Many of you chose B. Well done. Well done, y'all. So this is where if you remember I don't want to say rule, but the trend of metal end in M, this one you don't even need to memorize like the periodic table to know. It's almost like a language game, right? It's a suffix, looking at the endings of the words. All right, let's keep going. Which of the following combination of elements is most likely to share electrons? Think about this question. Okay, we're sharing. What does that mean? What's going to be the best choice? Let's take 30 seconds or so to answer this one. Awesome, getting a lot of engagement, a lot of responses. Keep it coming, keep it coming. Good, keep it up, keep it up. Awesome, y'all. Take 5 more seconds. All right. Love what I'm seeing here, y'all. So in the chat, can someone share? Can someone share? Can someone tell everyone what kind of bond is it if we're sharing? Can someone share what happens if we share? Is it covalent or ionic? In the chat, someone share that out real quick. Yep. Thank you, Jilly. Good job. It's covalent, right? Covalent again, same as last question, which means we're looking for, if it ends in M, it's not going to be possible to be covalent, okay? These are metals. Potassium is a metal, so it can't be A. No metals here. And not there. This is a metal. Can't be C. Sodium is a metal, so it can't be D. It's going to be B again, okay? So this is again one where we're practicing reading the names. Okay, read the name, check and see, is it metal or non-metal, and go from there, right? So there's kind of multiple parts. First, is it covalent? Is it ionic? If it's covalent, find the choice that doesn't have endings in M. But it's all good. As we say in my class, make mistakes, try again. Make mistakes, and students call back, try again, because we learn from our mistakes, and it's okay if we didn't get it. Okay. Now, next question. Which of the following combinations of elements is most likely to transfer electrons? Which of these is most likely to transfer electrons? Looking at our count, we got some more folks coming in. That's great. Hop in, answer the question in the chat. Let's talk about it. Take about 20 more seconds to answer. Let's go, let's go, let's go. Love what I'm seeing. Got a lot of engagement. Getting a lot of responses. Awesome. Okay. So first thing in the chat, can somebody share what kind of bond is this? It's saying that the electrons are transferring. So what kind of bond is that? I think I did see one comment that did correctly say it already, but just let's put it back up for folks to see. It's ionic. Yep, that's right. 4, 5, 6, 7 of you got it already. Great job. Yes. So now it's like, which of these choices has a metal? We're looking for that ending in M. Oh, lithium right there. Lithium is a metal. Oxygen, nitrogen, those are non-metals. Those are also, chlorine's a non-metal. Okay, carbon is a non-metal. These like, and hydrogen too, right? These are all non-metals. So the best choice is going to be, let me just make this a little bit smaller. Choice B, okay? Quick reminders, transferring electrons means ionic, sharing means covalent. If you're just coming in, quick reminders on bond types, write it down. I put a box here, but I can't move the box. Why can't I move the box? There it goes. And there's my other reminder. I was like, what was that reminder again? There it is. So if it ends in ene, it's going to be a non-metal. And I know that's not all of them, like iodine, fluorine, those are non-metals. Okay. Oxygen, also a non-metal ending. Carbon, honestly, N, non, ending in N is going to be a non-metal. Okay. I'm going to add N, ends in N, also non-metal, because that right there is going to be a really good tool, right? If you do not have a periodic table with you, which you won't have one, you don't need it if you remember these rules of language, for a question like this, okay? It's not to say it won't come in handy having those parts memorized I mentioned earlier, but still. This is a nice fallback. All right, love it. Love what I'm seeing in the chat. Yes, we're getting it. All right. Now, let's just do it this way. Which kind of compound is most likely to contain an ionic bond? Now, this is where having that knowledge of the periodic table would be helpful. Let's see how we do on this one. CO2, H2O, NaCl, or H2. What's going to be an ionic bond? Let's take like 20 seconds. Already got 2 answers. Keep them coming, y'all. Awesome. A lot of engagement, a lot of people answering in the chat. Love it. Got lots of responses. Keep it up. About 3 more seconds. Go over it in just a minute. Okay. So this is one where, yes, if I think everyone said the same answer. Yes, if you said C, then you are correct. Yes, this is ionic because it includes a non-metal and a metal. Okay, and it's also an example we saw earlier. So, paid attention, got the example, saw it in this. Well done if that's how you remembered it. But more importantly, this is where it comes in handy to know, like, okay, carbon and oxygen, those are both non-metals. Okay. Let's show it on the periodic table. So non-metals are going to be in this area, this section here. So carbon and oxygen, okay, non-metal. Hydrogen's not in this area, but it is like the one exception that's going to be over here in the first group. Okay, it's got the same number of valence electrons as all of these metals do, but hydrogen is not a metal. Okay, so hydrogen is going to be involved in covalent bonds if it's connected with another nonmetal. Oops, sorry. I'm going to cross off B. And then H2, it's 2 hydrogens, also going to be covalent, which means C is the correct answer because C is ionic. Ionic is transferring electrons. Okay, sodium chloride, you got the metal and the non-metal. Quick pause for any questions that might come up for folks at this point in time. All right, so now I want to talk about one more type of bonding that's pretty quick. We're getting close to our time, but I want to talk about this real fast as well. Okay? You're going to get a lot more questions about ionic covalent bonds on the test, but this is like one that, you might get a question on metallic bonding thrown your way, and I'm making sure you're ready for anything. All right, so this is a quick little mini lesson on metallic bonding, and then I have a couple questions to check understanding. I'm going to watch this little animation first, and I don't want you to worry about anything over here except these little dots bouncing around in there. Okay? All these little, electrons, those are electrons moving around really fast. And that's what electrons do. Electrons are moving really, really, really fast. Okay? Electrons are negatively charged. Okay? And in the nucleus, you can see these positives. The nucleus of an atom, the nuclei, plural, are all positive. And so a metallic bond is what happens between metal atoms of the same type. So like a metal bonded to another metal of the same type, unless it's maybe an alloy, which would be it'd be like, multiple metals, but all they're not like ionic covalent bonded. They're just kind of, mixed and melted together and solidified. Long story short, metallic bonds usually occurs between metals of the same exact type. Basically, like if you got a block of iron Okay, this is what would be happening inside of those atoms of iron. How it works. In metallic bonding, atoms in the metal are surrounded by a SEA, okay, of free-moving electrons. This explains actually a lot about why metals behave the way they do, if you think about it. These electrons are not tied to any one atom, allowing them to flow freely. And this is not like all the electrons in these metal atoms. It's like the outermost, the valence electrons, pretty much. That's what we come back to that big idea. Valence electrons in metals are going, if it's a chunk of metal, are going to be freely flowing, moving around the nuclei, which accounts for many of the properties of metals, which is like conductivity, like, they conduct electricity and heat. Think about electricity is the flow of electrons. You have these freely moving electrons in this piece of metal, and so that is what helps the flow of electricity actually happen. And I'm simplifying this a lot. Like there's a lot of physics going on there that I'm not an expert in, so I'm not going to go too much down that rabbit hole. But what I do know in my area of expertise is that the chemical property of electrons moving around is one way that, or one cause, I should say, for this property of conductivity. And also malleability. That means like you can, with a lot of force, you can bend a metal and it'll like retain that shape as you bend it to a certain degree. So how to recognize metallic bonds? They're going to occur in pure metals or alloys like copper or bronze. So if it asks you a question like what is going to be the bonding type in a chunk of copper or a piece of copper wire, it's just copper. It's only copper, not copper oxide, not copper chloride or whatever. It's just copper. If that's the case, it's got to be metallic bonding. So I know I'm throwing one more new idea your way, okay? But it's relatively quick when it comes to what you need to know about it. As long as we really understand it's this idea of a sea of free-moving electrons, and it accounts for properties like conductivity and malleability, you're going to be just set. You're going to be set. I think I meant to say just fine, and then I said set at the same time. What questions are coming up for folks as I'm talking about this new type of bonding that I have not mentioned today until now? Okay. Let's do a couple questions to check understanding before we close out. Okay. What type of bond allows for the free moving of electrons, enabling electrical conductivity in solids? Ionic, covalent, metallic, or hydrogen bonding? In the chat, what are we thinking? Sound off, sound off. Awesome, y'all. Take about 5 more seconds to answer in the chat. All right. Yeah. Basically, were you paying attention? If you were, then yes, you got C. And y'all crush this. Yeah, this is a question that you might see about metallic bonding. This is a good example of a question that might come up on the TEAS. Okay, that is not ionic covalent. It's gonna touch on this other type. Thinking again along the lines of what we described, what statement best describes a metallic bond? What do we think the best choice is here? Go. Take about 30 seconds. Read the choices. Pick the best one. Already got 2 responses. Good. Fatima, I can. Yes. Give me just a minute, okay? Let's go over this question first, and I can go back to... I'll go back to the last slide and the slide before that because I'm not sure exactly which slide you want me to go to, but yeah. Yep, the last question, I got you. Let's go with this one first, and then I got you. On this one, if you said it involves a sea of delocalized electrons surrounding positively charged metal ions, you are correct, because that's exactly what we talked about in our notes. And Fatima, I got you. I'll go back to that one as well. So it goes. That's what we talked about, right? This is the definition of metallic bond. So I'm gonna go back to that slide right now, take a screenshot of it, memorize the definition, and you'll be set. First, here is this question. Someone wanted this one. I'll let this one up for about 10 seconds. Then I'll go back to the previous one, and I will, and I'll do a quick like rapid fire review of what we talked about today. We covered a lot. Like, y'all should give yourselves a round of applause for everything you've done today. Y'all have done so good. Like, we covered so much. So I'll work backwards. We just talked about metallic bonding. Metallic bonding is a sea of electrons. They're freely moving around these positive ions, these positive metal ions of metal in that chunk of metal that we're talking about. That's metallic bonding. They occur between metal atoms of the same type. And then, kind of going back to the beginning, this all actually metallic bonding as well. Those free-moving electrons are going to be the valence electrons. Okay? None of what we talked about today would be possible without valence electrons. They are electrons on the outermost orbital of an atom. And they are important because they allow atoms to make bonds with other atoms. Of course. Thank you both. Thank you all so much. Yeah. The big idea here is that atoms connect with other atoms using valence electrons. And this happens, we learned about 3 ways today. Okay? Ionic bonds. As you can see, there's a transfer of electrons happening. And covalent bonds. Covalent bonds happen when you share electrons. And this rule is followed most of the time. It's called the octet rule in ionic and covalent bonds. Atoms tend to be stable when they have 8 electrons in their outermost orbital, their valence orbital. All right? Ionic bonds form when a metal transfers its valence electron to a nonmetal. And then I also talked about, covalent bonds form when 2 nonmetals share electrons so that they have a full octet. Hopping on. Hey, welcome to, we're wrapping up chemistry, but there might be another session happening shortly after this. So the periodic table, I would, again, memorize this part and this part, and when you're memorizing each square, look for the atomic number, atomic mass. Obviously, the name is going to be on there, group number, and the number of valence electrons. And we talked about how you can look at this. This would be a good one to screenshot. The valence electrons there's a pattern in each group, okay? 8 here, 7 here, 6 here, 5, 4, 3. You skip all these, 2 and 1 valence electrons. All right? Great job to everybody. You should be proud of yourself. Okay, again, I'm Brandon Piasecki, and I love to be a small part of your journey on becoming a nurse, becoming an incredible nurse, to serve our communities here. So I just appreciate all of your time and kind words and engagement. And yeah, unfortunately, I won't do another one this week for chemistry, but there are other live sessions throughout the week that happen from other amazing instructors, y'all. But I'm here every Monday from 4 p.m. Pacific time or 7 p.m. Eastern time, okay, for a whole hour, okay? And check out the Nurse Hub website with so many other free resources, but also if you subscribe, then you can gain access to even more. You can even watch lives back. And there's a lot. There's also lessons on NurseHub. There are lessons that you can look at if you subscribe. There's also some videos of lessons that I have created and helped create with the NurseHub team that you can look at for just looking at some things in more detail. So yeah, check it out, y'all. There's a lot of great stuff there. Okay, appreciate you all so much, and I will see you next week. Thanks, Mitch. No worries. You're good. Yeah, a lot of free resources to check out. Make sure you check out the free resources on nursehub.com, y'all. It's going to be great. Okay. Have an amazing week, and I will see y'all on Monday.